that side. Now I'm going to explain about halfwave rectifier. So my topic is about halfwave rectifiers. I'm going to explain about halfwave rectifier. This video representation is all about halfwave rectifier, its working, its types, it's about its parameters, its working principle parameters, and some numbers of the parameters. And the subject is, now I'm going to explain about the subject electronic devices and circuits. So I'm going to start half-wave rectifier. Yeah, so I want to introduce some theory about half-wave rectifier. So it's kind of what is half-wave, what is the definition of half-wave rectifier. So the ideal definition of half-wave rectifier is a half-wave rectifier converts alternating current, that is AC current, into pulsating DC current by allowing only one half of cycle to pass through it. So a half-wave rectifier is an electronic circuit that converts AC alternating current into DC alternating current by allowing current to only during positive half of the cycle of the AC input. So it is the simplest type of rectifier, typically using a single diode, which uses only a single diode. So the diode is widely used in power supply circuits for small application and signal detection, which is used to detect the signal. So now when you there are two types. We have full wave rectifiers. Now it's all about half wave rectifiers. So working principle of half wave rectifiers. So it uses only one diode. I already know that. I already told before introducing the half wave rectifiers. It uses only one diode connected to AC source and a load resistor RL. So during the positive half cycle of the AC, the diode becomes forward bias and current. When it is in forward bias during the positive half of the AC, and it conducts current. During the negative half cycle, the diode is reverse bias. It prevents current flow. That means the diode blocks current. So thus only positive pulses appear across the load, giving pulsating DC. So as a result, only positive half cycles are transmitted, creating a pulsating DC output. So when it comes to the types of half-wave rectifiers, yes, there are mainly two types of half-wave rectifiers based on the transformer connection. Type 1, uncontrolled half-wave rectifier. Using a normal PN junction diode, the current output depends purely on the AC input waveform. So that is simple diode plus load. The circuit consists of. So controlled half-wave rectifier, the second one, uses a thyristor, that is a SCR. Instead of a diode, the output can be controlled by changing the firing angle alpha. So the circuit consists of mainly built by using can be built by using SCR diode, load and firing circuit. So the working this is the working principle, types and introduction to half-wave rectifiers. When it comes to circuit diagram, the later circuit diagram of half-wave rectifier. The basic circuit includes AC power source, that is AC 230 volts. That is we know that 230 volts AC supply, 50 Hz frequency, a single diode and a load resistor. This is the basic circuit of half-wave rectifier. So the AC input is connected across the diode, which is oriented to allow current during positive half cycles. So it allows only current in only positive half cycles only. The load resistor is where the rectified voltage is developed and can be measured. So we know that circuit diagram, it consists of AC power source and a single diode and a load resistor where we took the output. So the AC input is connected across diode, which allows the current to flow only positive half cycle. During negative half cycle, the diode blocks the current. So when it comes to output waveform characteristics, the output voltage waveform is a series of positive half cycles with zero voltage during the negative half cycles, because we know that the diode blocks the current in negative half cycle. The waveform is pulsating and contains ripples, indicating it is not pure DC. So the half-wave rectifier does not convert AC into pure DC. It converts pulsating DC. It consists of some ripples. We doesn't get a full DC waveform. So the peak voltage of the output is approximately equal to the peak of the input AC voltage. So what we have given at the AC input voltage approximately equal to the AC voltage only. Minus the diode's forward voltage drop. There is some drop across. There is some voltage drop. So when it comes to advantages of half-wave rectifiers, they are simple in design. It is easy to conduct, where it consists of one diode, a load resistor, and we have given AC input. So they are inexpensive, somewhat, and require fewer components. It requires minimum 3 components, or 2 components and the AC supply. Suitable for low power applications, only for low power application. If you give, this is not, because the circuit builds a simple circuit. It is suitable for low power applications where size and cost are critical factors. So it has some disadvantages also. So because that is low frequency, they have low frequency with only half of the AC waveform utilized. Only half of the waveform is utilized. We cannot get the full waveform. The name itself tells that it is an half-wave rectifier. The output contains high level of ripples. I already said earlier that the half-wave rectifier only converts AC into pulsating DC. It doesn't convert AC into pure DC. So the output contains high level of ripples, requiring filters to get pure DC or smooth DC. They generate more transformer diode stress due to higher peak currents. So in output waveform, only positive half cycles appear across the load. So output is pulsating DC, require few filters like capacitor or inductors for smoothing. So filtering techniques for better output. If you want some better output before what we got, so how to a filter capacitor is used, as I said earlier. It is commonly used to reduce ripples and produce a smoother DC output. An inductor or a combination of inductor plus capacitor, that is we often call it as tank circuit, can also improve the output quality. So proper filtering significantly enhances the performance. If you done proper filtering, it can enhances the performance of the half-wave rectifier circuits. So where we can use these half-wave rectifiers, rather applications of half-wave rectifiers used in small power supply such as battery chargers and signal detection circuits, employed in experiments, educational demonstration to illustrate rectification, small rectifications, suitable where only a small amount of DC power is needed or cost constraints exist. As we know that usually it does not take that much of a cost. So when we compare it to full wave rectifier utilize both half cycles, whereas half wave rectifier utilizes only half of the cycle. It is positive half cycle, we know that, resulting in higher efficiency, smoother output in full wave rectifier. But in it produces high ripples in the half wave rectifier. We doesn't get that much of efficiency. You know the output of half wave rectifier, which is not lethally compared to full wave rectifiers. So half wave rectifiers are preferred for simple low power applications due to straightforward design. Whereas somewhat when it comes to a full wave rectifiers, half wave rectifiers are constructed very with the low cost. The efficiency also that much low. So the full wave rectifiers are constructed with not big circuit. When comparatively full wave rectifier circuit is big, large. It can be used in higher power applications. So when it comes to parameters of half wave rectifier, average DC voltage VDC equal to VEM by pi. So its typical value is 0.318 into Vm. So RMS output voltage Vrms equal to Vm by 2, 0.5 into Vm. So the efficiency in half wave rectifier is PDC by AC ADC. So that is power of DC by power in AC. That approximately 40.6%. So the typical value is 40.6%. So it is less efficiency when compared to full wave rectifiers. So the ripple factor of half wave rectifier is 1.21. Its typical value is poor, very poor. So high in the sense the ripple factor must be low, right? If you want higher efficiency, the ripple factor must be low, but this is very high. That means it's poor. So when the form factor equals to Vrms by VDC, that is 1.57 in half wave rectifier. Peak inverse voltage, that is PIV equals to Vm, that is Vm. Transformer utilization factor TUF equals to 0.287, that is very poor in half wave rectifier. So the conclusion and is the half wave rectifier converts AC into pulsating DC by allowing current during only one half cycle, that is positive half cycle. Despite their simplicity, even though it is less cost, simple to construct, but they have their limitations like low efficiency and high ripple content. So they remain useful in specific applications, low power applications, like where simplicity, like in designing circuits of low power designing circuits, and cost are more important than efficiency in this half wave rectifiers. So as I mentioned in earlier, there are which type is best in basic purpose. When it comes to basic rectification, uncontrolled half wave rectifier, because it's simple and low cost, even in the STU also. If in the purpose is variable DC output, controlled half wave rectifier, that is SCR based. SCR the load, that construction which consists of allows control over DC voltage using firing angle. We use firing angle in SCR based rectifier, that is control half wave rectifiers. In between two, however, in practical applications, half wave rectifiers are used due to rarely used due to poor efficiency. So instead, engineer prefers full wave rectifier, that is center tapped or bridge tapped, because their efficiency is somewhat more. Its efficiency is 40.6, but its efficiency in full wave rectifier is somewhat close to 81.2%. Ripple power is also low. So if ripple power is high, that is poor. Transformation utilization is higher, that is not suitable. So when it comes to summary, we use that half wave rectifier uncontrolled, diode is used, half wave control is SCR used, output control is fixed in controlled, adjustable because it has its firing angle, because it is SCR, and efficiency is 40.6%. Here also less than 40.6%, but depends on firing angle. Ripple factor is high in both controlled and uncontrolled half wave rectifier. The cost is low in uncontrolled, somewhat moderate in controlled half wave rectifiers. In practical use, uncontrolled rectifier is used in signal demodulation and testing. It is controlled half wave rectifier used in power control and speed control. So that's it.